Hello students, in this video we are going to see the second law of thermodynamics. We already studied the first law and we have discussed many thermodynamic processes also from the first law. But first law tells about heat, work and all. But first law did not say from where to where the heat will transfer. First law did not say till when the heat will transfer. The answer for these questions we already know. Heat will be transferred only when both of them only till there is a temperature difference, and heat flow will stop when both of the bodies attain same temperature. That is common sense. Then heat can always flow from hot body to cold body. That is also common sense. But using first law couldn't explain these things. That was the drawbacks of first law. So you can just give the heading limitations of first law of thermodynamics. The first limitation, it does not indicate the direction of heat transfer. It does not indicate the direction of heat transfer. The second point, it does not tell anything about the conditions under which heat can be converted into mechanical work. Third point, it does not indicate the extent to which the heat energy can be converted into mechanical work continuously. Till what extent? So, to give answer for all these things, to solve all these limitations, I already told heat can be converted into mechanical work only up to a certain limit. When the system temperature and the surrounding temperature, both of them are equal, then heat transfer will not take place. Then no more heat can be converted into mechanical work. So these all things could not be explained by first law. That is why the second law is introduced. Second law of thermodynamics is introduced by two scientists. First one's name is Kelvin Planck and second one's name is Clausius. So Kelvin's Planck's statement is telling that it is impossible to construct an engine which will produce no effect other than extracting heat from a reservoir and performing an equal amount of work. That means no process is possible whose result is the absorption of heat from the reservoir and complete conversion of heat into work. In short, I can say like this: there is no engine that can convert 100% of heat into work. That is second law. Second law, the Kelvin's Planck statement. This law is applicable to heat engine, because heat engine, the engines that we use in cars, all the vehicles. Steam engine is also example for heat engine. So no engine can convert heat into work. No engine can convert the entire amount of heat, 100% of heat to work. Now comes the Clausius statement. Clausius statement is telling like this: it is impossible for a self-acting machine unaided by an external agency to transfer the heat from a body to another at higher temperature. It is impossible for a self-acting machine unaided by an external agency to transfer heat from a body to another at high temperature, which means heat can be transferred only from high temperature to low temperature. What else if I want to transfer heat from low temperature to high temperature? That is not possible unless an external agency work on it. Usual heat flow is only from hot body to cold body. In the fridge, in refrigerator, you can see, you keep the food items in the refrigerator, and after some time the food is getting cold, and by the time when you touch the side of the refrigerator, it is becoming hot, and as the fridge keeps on working, the sides of the fridge will become hotter and hotter and hotter. How come that happen? Here heat is taken from the cold container and it is given to the surroundings which is already hot. So that type of process can be done only with the help of an external agency, and that external, in the case of refrigerator and air conditioner, that external agency is compressor. Compressor does the work for that. So the cool room becomes cooler and cooler, the outside, the surroundings becomes hotter and hotter. So heat is taken from the cool room to the surroundings so that we keep the room cooler and cooler. So that is Cauchy's statement. No process is possible whose result is the transfer of heat from a colder object to a hotter object. That is why I told unaided by an external agency, this cannot be done. If an external agency work, it can happen. So just see the explanation of Kelvin's Planck statement. It is always impossible that the total amount of heat which is supplied to a system will get converted into work. There will be always a loss of heat. Complete conversion of heat into work is not possible. And this one we have already done in the case of refrigerator, the explanation. Now see reversible process, reversible and irreversible process. What is meant by reversible? The process is reversible only if the process can be turned back such that the system and the surroundings return to their original state with no other change anywhere else in the universe. That means there should be a change taking place and it has to reverse exactly in the same manner without disturbing the surroundings. For example, evaporating the water slowly, not boiling, okay, evaporating the water slowly, the water goes, and when it reaches, slowly it has to be cooled and then come down. So slow evaporation and slow condensation can be taken as a reversible process. Boiling will not be considered as reversible. It can be cyclic. When I boil it and then condense, I will get water, that is cyclic process, but the system should, how the system has reached that stage, in the same manner the system has to come back. That is called reversible. So this means in the reversible process, if a process starts from initial state, then it goes to final state, and then it can be reversed back from final to initial state in the same process. Example they are giving isothermal expansion and compression, and the second one electrolysis. Isothermal expansion, slowly you compress the gas by pushing the piston down. So when the piston is pushed down, the heat will be given out to the surroundings so that temperature of the gas remains constant. Similarly, when you take it up again, heat is taken from the surroundings so that the temperature of the gas is constant. So that process is reversible. Slow evaporation and slow condensation is reversible, but boiling and cooling is not reversible. Now electrolysis. Electrolysis will be a reversible process if the resistance is nullified, but the wires will be having resistance, so it is not perfectly reversible. If the wires are having no resistance, the process electrolysis is perfectly reversible. So, the process is reversible only if it is quasi-static. No dissipative forces, that means there is no loss of heat by friction, etc. Both the initial and final state of the system are in thermodynamic equilibrium with each other. Now see irreversible process. Usually it is very difficult to see a perfectly reversible process. Usually all the processes which are taking place are irreversible. Most of the processes which are taking place are irreversible. So, irreversible processes are those processes that cannot be reversed. So, the two causes which give rise to irreversible process, there are two causes. First one, the process taking place at a faster rate. So, for the perfect exchange of heat, they will not get enough time. So, irreversible process, they are taking place at a faster rate. Second one, dissipative effects. That means energy will be wasted as heat, energy will be wasted as sound, or friction, due to friction energy will be wasted. All those things are there. That is why the processes are irreversible. Example, plastic deformation, combustion, diffusion, falling of water. So, all those things are irreversible process. So, in the nature, most of the process that we are seeing is irreversible only. So, with this section comes to an end. Our chapter also finishes by this. Hope you have understood this. This chapter is basically main on the theory. So, a lot of conceptual questions, application level questions and all can come from this chapter. We have only one derivation to study, that is the Mayer's relation. So, please complete all the notes. Okay, thank you.